The Higgs boson particle has made waves in the scientific community with its revolutionary discovery. Thanks to the Large Hadron Collider (LHC) at CERN in Switzerland, we are now able to observe particle collisions and potentially discover new particles that have yet to be identified. This is where the excitement lies, as uncovering new particles can give us valuable insights into the beginnings of the universe and the events of the Big Bang. To identify these new particles, scientists are tasked with processing vast amounts of data and categorizing the resulting collision-generated particles into two groups: those that are potentially interesting, referred here as signal particles, and those that are not, referred here as background particles. This is where the role of machine learning comes into play. CERN scientists need your help to assist in the search for the next revolutionary particle that could change our understanding of the universe. Try out the Fur Universe Challenge and be part of a new scientific discovery that could shape our future. Now let's dive into the specifics. The challenge might sound pretty straightforward at first, a binary classification based on the features of each particle. However, it is not as simple as it sounds. In real life, certain scientists are having trouble classifying the particles because of the presence of noise. Therefore, we need the help of motivated students to help us tackle this classification problem even in the presence of a bias. The particles are converted into many features in real life, corresponding to many physical measurements and properties of the particle. However, scientists deem sufficient to only have the particle's 2D coordinates as its only two features. Here we will refer to them as x1 and x2. Scientists can simulate hundreds of these collisions in order to generate as much data as they want. In this challenge, therefore, we provide data that is generated by a program that introduces a bias on one of the parameters or multiple parameters of data distribution. Here's how the data is generated and the bias introduced into it. In this image, you can see two pairs of blue and red circles that represent background and signal distributions. First, the pair at the bottom has no bias and depends on four parameters. Then, to generate the biased pair, the second pair at the top, we translate the first pair in a specific direction with a specific magnitude. This transformation corresponds to a modification in parameters z and alpha in this concrete example. You'll find more details on the parameters on the website and in the starter kit, where we will guide your first steps in the competition. Your job will be to create a model that is therefore invariant to all these possible biases. You will need to create a solution that is able to perform well on all the tasks that exist. We define a task as a problem of classifying, as accurately as possible, signal at background points when given a dataset that contains one of the possible parameter combinations that introduce bias through a transformation. As it is a classification problem, we are using AUC or ROC score as our metric because we care equally about the true negatives as much as we care about the false positives. More details on the data, the bias, the metrics, and the classification baseline algorithms we use in this challenge will be available in the CodaBench website. Last but not least, I must remind you that this is a competition, however collaboration is not only allowed but encouraged. So what are you waiting for? Scan the QR code that you see on screen right now and get right into action and help the progress of science by joining the Fur Universe Challenge.